Hi guys, this is Math 148, section 12.1, and in this section we are starting integrals. What are integrals? Well, they are the opposite of derivatives. They are yin to the derivatives yang. Maybe it's the other way around. So here's the basic problem. Suppose you had the derivative of some function was equal to 4 times x cubed, and you said, haha, what is the function? So what function has the derivative that is 4x cubed? Some of you could probably say, just see it right away and say, oh, that's got to be x to the fourth, right? Because the derivative of that is 4 times x cubed. It looks like a star, it's an x. So integrals are a way of formalizing this process. So rather than having to guess every time and say, oh, I think I see it, we actually have rules and formal things we can do that allow us to take integrals and find the function for which we have the derivative. Integrals are, in my math studies, I did integrals much more than I did derivatives, mainly because I did a lot of probability, and probability is all about areas under a curve, which is the integral. So you'll get to that later. Here's rule number 1 of integrals. Rule number 1, it's based on this sort of idea, is suppose you have the integral of some function that looks like x to the n, where n is some number, and we always write this dx because you just took the derivative. So the dx kind of goes with the fact that that's the derivative. Okay. The rule is if you have this integral and this swoopy looking f thing, that means the integral. That means integral. The integral of x to the n dx. This is equal to, this is the rule, 1 over n plus 1 to the x times x to the n plus 1 plus a constant. Okay, where does this constant come from? Well, let's go back to this problem here. Suppose we had the function f of x is equal to x to the fourth plus 3. Well, the derivative of that is equal to 4x cubed, right? And this 3 goes away. So when you take the integral, you have to add a constant just to represent some number that may or may not be there, that when you took the derivative, it went away to 0. So for these, you don't have to necessarily spend a lot of time really understanding, where that constant came from. Just remember, all of these get a constant at the end for now. Get a constant plus a cookie. You get a cookie. All right. So here is an example. This is question number 5 on your homework from the 10th edition. Find the integral or take the integral of x to the 7th dx. Well, this squarely fits into our formula that we have here. We have a function that is x to the something, so we're going to use this rule. So we take the 7 and you add 1, so the answer is x to the 8, and then take 1 over 8, and then you get a cookie plus a constant. I say add a cookie, but I like cookies more than I like constants. So that's question number 5. This is your answer. So when they're in this form, it kind of goes fast. So here's question number 7, and this is illustrating another rule, and here is the rule. You can factor out a constant. It's not this constant. If there is a constant number in front of your derivative, you can factor that out. So suppose we have a derivative like this. This is question number 7, the derivative of 8x cubed dx. We're taking it in terms of x. So we can pull the 8 out in front. 8 times x cubed dx. So that's what I mean when I say factor out a constant. The 8 can come out in front. So that becomes 8 times this whole thing. Look, it's back to this perfect form. I take x. Sometimes I like to do this part first. Plus 1 is 4, and I take 1 over 4. Haha! Now the 8 and the 4 cancel, so the answer is 2 x to the 4th plus a cookie, plus a constant. If you don't put a constant there, you get minus 1 point. It's not a big deal, but you should put your constant in there. Okay, so that was question number 7. Here is another little rule. Suppose you have the integral of a constant. Integral of a constant, which would look like this. This is question number, I don't know if it is a question. Suppose you have the integral of just 8 dx. It's not 8x, it's just 8. So this is equal to 8. You can factor the 8 out in front, or it's just 8 times x plus a constant. So the rule is the integral of some constant I don't know why they use c for all of these, is equal to the constant times x, maybe it's a little c plus your big cookie constant that was left over. So again, try not to worry too much for now about what this constant is. It just could be any number. They're saying we don't know. There's lots of functions that could have this property. So one way I remember these derivatives, if you think about it, this is like 8 times x to the 0 dx. So you could still use the other rule. That's 8 times, you add 1 there, x to the 1, and then 1 over 1. So it's just 8x. But this is the rule of the integral of a constant. Okay? And for all of these functions, you can check your work when you're done by taking the derivative. Check with derivatives. For example, suppose you think, oh, I think this is the answer. Well, let's take the derivative of this. The derivative of 8x plus a constant is 8. And that was the function, right? 8. Check. Let's go back to this one, right here. The derivative of this piece, I'll do it in yellow, is 8x cubed, right? The derivative, and that was what we had here. Check. So that's how you can use derivatives to check to make sure your integral is the same. You're just going back and forth, just getting really easy and breezy with derivatives and integrals. So we can add and subtract integrals, which makes these very nice. Kind of like you can add and subtract the derivatives, you can add and subtract integrals. And I'll show you what this looks like. Question number 13. We have the integral of x to the 4th minus x, or 9, sorry I said x, 9x squared plus 3 dx. So we're taking the derivative in terms of x. So what this means, when I say we can add and subtract, that's the same as the integral of x to the 4th dx minus the integral of 9x squared dx. You can do each piece separately and then add them or subtract them. So this right here, integral of x to the 4th, well, that's our nice rule. So we can say x add 1 is 5 and take 1 over 5. You can say, what about the constant? Sure, I'll show you what happens to those in a second. 9x squared, well, the 9 comes out in front, and then you add 1 here, so that's x cubed, and take 1 over x cubed. Remember, because the 9 is a constant. Plus, see how these are all adding up? So this one is 3 times x. And this one, you could say, what, this one had a constant, and this one had a constant. You got 3 cookies. But no. What happens with these constants, since they're just some number and we don't really have enough information to know exactly what that number is, we reduce them all and just write one constant at the end. So here's your final answer. You say 1/5 x to the 5th minus, those cancel, 3 x cubed plus 3x plus some constant. Since we don't know what these numbers are, we can just add them all up and they'll make a new number, so we just add a constant at the end. So really the pattern you're going to get in the habit of is for these, they call them indefinite integrals because there's no numbers here, as we'll see in a minute when we get to other sections. So add a constant. So this is the answer to question 13. I have one more in this section. This is, for the most part, all of what is in 12.1 is just these early and sort of elementary beginning rules for integrals. Question 27. Integral of x to the 9th minus 1 over x cubed plus 2 divided by cube root of x dx. All right. So we can take each piece and do it separately. First I'm going to rewrite this just to make it nice looking as the integral of x to the 9th minus x to the -3, right? That goes up top, becomes -3, plus 2 times x to the -1/3. Again, this cube root is 1/3 like that, and so it's negative when it comes up. So I've just rewritten the function, or the integral. So in order to find the integral now, you got to really love these ones that are just x raised to some power. So that's going to be 10. You add 1, and then do 1 over 10, minus, add 1, so that's x to the -2, and then write 1 over -2, plus 2 times, because the 2 factors out in front because it's a constant. So it's x, minus 1/3 plus 1 is 2/3. And look at this, you go 1 over 2/3. Some of you would automatically flip that, which is completely fine, plus a cookie, plus your constant. X to the 10 plus, the minus minus, 1/2. The book writes it like this, x squared instead of x to the negative 2, that piece right there, plus, so this 2 times 1 over 2/3 is the same as 2 times 3 over 2, so the 2's cancel, 3 times x to the 2/3 plus a constant, and that is your answer. I'll try to make a square around it. So this basic formula right here, this one, no, right here, this one, this is really going to carry you through a lot of this section. So you should be familiar with this and do enough problems so that this feels pretty comfortable and routine to you. So look over your homework and do a bunch from this section so that you get these integrals, so you get very comfortable with them, and let me know if you have any questions.